Hello, fellow learners of the Open Polkadot Bootcamp made by the OpenGuild community. I'm Chung and welcome back to our session today. Today we're gonna learn a very interesting topic, deep dive into development on Substrate, like especially like building a custom logic for the Substrate blockchain. So if you are new to the Open Polkadot Bootcamp, remember to revisit like the previous section to learn about Substrate and also like Polkadot. Adding a custom logic to a runtime. So as we already learned in the previous sections about Substrate and Polkadot SDK, we know that like the runtime is the upper level of the Substrate node of the whole like blockchain network that specify like all the core programming logic for the blockchain, like asset management, NFT governance, treasury management, and also like something like on-chain identity. And today we also like want to build something similar to that, adding custom logic to a runtime. To like programming runtime module called palette. Here we have a very interesting graphic that I think like every Substrate learner should like remember. So this one is the runtime module. Runtime module is built on top of like a lot of like frame libraries, and the frame libraries help you to build the runtime logic easily and don't have to care about like the complexity, the underlying complexity of the blockchain programming. So frame like provide you a lot of like frame support libraries with the macro, the type, the tree, and the helper modules that we're gonna see in the real code later. So the underlying of every frame palette is the frame system module that like handling the account, the block number, hash, header, origin, and version. So what we're gonna learn today, the first thing gonna be like the component of palette and a very basic component, and also like, we're gonna look at the code and like try to programming a bit. Before like we learn like a few examples of the Substrate palette, we want to quick go through basic flow and also like basic component of the palette. So here is like our palette aka as known as like the runtime module. So the palette gonna have like a few different components here. The first one gonna be the storage palette, similar to the smart contract. Also I need its own storage. So the storage in the palette gonna have different common storage type. The first one gonna be like bounded vec, that is like the vector that is bounded with like a specific length. The another one will be like storage end map. That like a storage that has like the end key mapping to like one specific value. The storage value is just imagine it's like a constant, like a single value. Or we can also like call it a scalar. Storage triple map is a storage map that has like two key mapped to like one value, and we're gonna see it in the real code later. The another one will be like the event. So for the palette, whenever like something execute on the palette, we want to emit the event so that the user can see the event and what just happened. The another one will be like the error. So when we have our functions we execute, that we also like want to throw an error, right? Very basic. So the another one would be like the dispatchable function. This is like one of the most core component of the palette, and it acts as the entry point for all the functionality of the palette. Dispatchable function, in terms of Substrate, we can also like call it extrinsic, because whenever you dispatch a function, it's gonna like generate a new. It's basically like generate a new transaction and submit to the change. Also like call it extrinsic. Dispatchable function gonna responsible for like handling the customer to customize the programming logic of a change. The another one would be a hook. So a hook like similar to React, if you're familiar with that. So like in React, you're gonna have like a few hook like a use effect, or use layout effect, use state, something like that. When you like execute a hook, for example, you use effect. The use effect in React is simply like whenever the component, like whenever your UI component render is gonna execute the things defined the use effect hook. In case like you're not familiar with that, so the hook in Substrate is gonna have a few different hook. For example, like on initialize and on finalize are two most like common hooks. What is like on initialize and on finalize? So for the on initialize, it's gonna execute at the beginning of the before like the block initialize, and on finalize, when the block finalize, it's gonna execute those those logic you define in the on finalize. There's other few things as well, for example, like transaction extension and size extension. transaction extension basically a replacement of the side extension, but I put these two as like two separate component here because like they have like different structure, but later on like the transaction extension gonna like replace the side extension completely. But I think like in the previous section we also like go to the side extension on the runtime that basically like wrap the transactions with another type, and then like gonna like check and validate, and also dispatch something before like when like you submit the transaction. The origin is basically like the one who submit the transaction in terms of the DAO. The origin can also like become like the member of the DAO, and you might want like only the member of the DAO can execute these dispatchable functions. As we already understand the architecture of the palette, and you might curious like how the real code gonna look like, how like the real palette gonna look like, and how you can implement it in the code. So remember like our Polkadot SDK minimal template that we just clone or like created using like Pop CUI in the section 1 or 2. Now like we gonna reuse that Polkadot SDK minimal template. We add a new template using like Pop CUI, using like the command like called like pop new palette. If you don't remember, you can rewatch. But when you already have the palette, here is the template the palette, and I already like provide like some to do here so that we can like follow and then complete our challenge. Following the structure of this to-do, first we're gonna like try to implement this a few storage, then the error and the event. And the reference that I'm gonna like take a look at is the real Polkadot documentations that like guide you to like how to implement all these things. The first thing would be like the storage, and as you remember, for the storage you want to have a storage to store something, right? And in this case we're gonna like build the palette, see something similar to a palette balances that can store the issue token, and also the balance of the account. So the first storage that we want to add is the total issuance. Now we go back to our palette, add this code and the balance. Here is hard code, the balance type gonna be like U128. The another storage type would be balance, and quick go to the total issuance. So this one using the storage value, the Scala type, and in the storage value there's another type called query kite, option query, or the value query. And you might like curious like what is the option query and the value query. So in the option, when you specify it as the option query, and when you retrieve the data, if there doesn't have any data in the storage items, the data would be options. So let's say it's gonna be like option balance. But if you like specify it as like value query, then the value return gonna be like the balance instead of the option type. And now we go back to the balance, our balances. So for the balances, we want that like mapping. We use the storage mapping. Let's say using like the black 128. This is like the hashing type for our key, and we're gonna like revisit that sometime in the future about like the hashing type, the storage key, and on which key that we should use in for the balances. And go back like for the balances. We wanted to map like the account ID. Here like we need the hashing type over our storage record, so that we don't like to like protect it from the security vulnerability if in the futures, because the blockchain is a public computer system, and it can be like more sensitive to be attacked like other like other malicious actors instead of just like some web server or like backend server. So here like we specify the account ID and then the value of the balances, maybe like call it so the balance. And we want to like, so what happened if like you don't, if your account doesn't exist in these balances yet? So we wanted to specify as the value query as well, because like when you query it, it's gonna return 0 instead of the option type. And to specify the storage in substrate palette development, you have to add the macro called like palette storage. This fam support storage provide you like all type of storage that you can read. So for example, our storage value, a trait for working with macro generated the storage value under the substrate storage API. We also have a storage map that we just use a strongly typed map in storage. It's similar to an object in like Python or like JavaScript. Go back to our code. So we already have to storage type, and following the guide, we want to add a new method called min unsafe. And this method gonna like safely mint a new token to the account and increase the total issuance tokens. Dispatchable functions. So how to implement the dispatchable functions? We want it to be implement palette. This is just basically Rust and doesn't have any crazy things here. So remember, it should be core. Yeah. We already have our needed skeleton, and right now it's throwing an error. So when you look at the Rust Analyzer error, you're gonna see that invalid palette core must have at least origin argument. What does that mean is when you define any functions under the macro palette core, now these functions gonna become dispatchable functions, and the dispatchable function must follow a structure that like every function must have an origin, specify who submit that dispatchable function, right? This should be the origin for. If I remember correctly, origin 4, and so our transfer, so they need origin 4. There's still an error because it wants us to return a dispatch result. It's just some special result type from substrate that asks you to return that for every dispatchable function. Okay. That like whenever you don't remember something, revisit Polkadot SDK. The main point is like to understand like how this work instead of like trying to remember syntax, because like substrate is still a framework, right? And like you cannot remember all the things in substrate. You mainly like, understand how it works under the hood, and then like just read the doc and copy it over. Now I think let's mention something about the weight. So I think like I'm gonna like specify the weight as default. Okay, seems perfect now. Our code is compiled, and we're gonna want to implement some core logic of our dispatchable functions. Go back to the guide. So the guide, we want to implement a method called transfer amount. Now the purpose is gonna be like to implement this method. And so we already like get to, just to recap, we already like get to like implement a new storage, and now we want to implement a new dispatchable functions. This dispatchable function later like gonna ask for the event and the error. In fact, like the event and the error are optional, but like in the real production code of the substrate, you want to implement this type. The min and safe is like to min and unsafe means that can be called by anyone, not a real idea. This actually like in fact, you want only like the super user, the first origin can be allowed to call this min unsafe method, and we're gonna like upgrade our palette later. But like right now, we're gonna like allow anyone to mint our tokens. And when you mint, you want to specify like how many tokens you're gonna mint for the account, right? And we're gonna specify like the balance. Maybe let's call it destination. First is about the account ID. I think it should be account ID of. And later we're gonna like how much you want to mint balance. So we have the balances and we want the balances. How do you know? When you work with straight, you might realize that like the Rust analyzer doesn't work very well with straight, and also captain like suggestions gonna like stop working when you work with straight at some point. So you might want to read the doc. The doc gonna be like your closest friends. So get back to our storage doc, and because we use the storage value, right? No, here we use the storage map. And when we look at the map, you're gonna find there's a few different items in the storage map that are insert that you want to mint. Insert is basically let's set a new value, but doesn't override completely. Instead of like trying to accumulate to some kind of existing record. So we don't want that. Maybe mutate exists, but I think like mutate exists doesn't need it because like you set the value curry. So like the balance is always 0, so maybe you can use mutate and go back to our code. We can do like mutate, specify the key. What is the key? The balances gonna be like the account ID, right? The destination gonna be our key, and then it's gonna return the balance. So, and I want our balance to saturating. Saturating, so it should be saturating at balance. Saturating at balance. New balance. No, let's say this call. I don't know what should be. Let's call it balance. Okay, let's say it's compile. Remember like to use cargo check every single time whenever you add a new code. It make you easier to compile. Can I infer? Yeah, you have to add infer the generic type T here. And then you're gonna pack. Maybe you should run bacon check and keep it all the time to see like if there are any error throwing. And right now you see like there's no error. Just some warning, but it's not important. And balance, and we also like want our total issuance, and go back. We also like want to know what is like the method that the storage value provide you. So this storage value storage type gonna provide you the put, set, tag, get, and we want to increase the value of the storage value. So maybe we could use mutate as well. That mutate to the existing value of the total issuance. Mutate. For the mutate, you doesn't have to specify the key because it's just in the Scala, and you want it to issuance, saturating. Add. What's the value? Gonna be the balance. Check. Okay, no error. So there's something missing here that we doesn't use our origin, and it also like throwing some warning in our code that like origin is not used. And this is not good because like when you receive someone like who dispatch that method, we want to make sure that like our transaction is signed by that one. Instead of, even though like this method is allowed by anyone, but we also like want that account to sign instead of like just submit it randomly, something like that. So we call ensure sign and then origin. So what this ensure sign gonna do? That it is ensure that the origin O represent a site is intrinsic. Transaction return OK with the account that site is intrinsic or an error otherwise. That is make sure that like the origins already submit an intrinsic or a transaction that is signed by the origin. So our method like look good now. Maybe we could write some tasks, but not at this moment. So keep it later. Now we come back to our sales extension. So let's say if there's anything missing. So instead of the saturating add, I might want this to use check add, and then I throw an error instead. So it's going to be the check add, okay, or arithmetic error overflow. And when you do that, you have to use try mutate. So that try mutate allow you to return a dispatch result instead of just avoid callback. Same things for the total issuance. Try mutate dispatch result. Then like okay. Now so good. So now this gonna return arithmetic error overflow instead of just saturating. Okay, go back to our guide. So we allow anyone. Yeah, so as you can see in the guide, it's used the method unwrap and then like using the plus command, using like the plus. But I don't like in practice. Like the good practice would be like not to use any like arithmetic operations that gonna like panic. So we don't want like our runtime to be panic, because like when the blockchain runtime panic, that's mean like all the chain gonna dead. So you don't want that. You want it to be like first gonna like saturating. Like if you like, it hit the ceiling or it hit the bottom value, then it's just saturate at the bottom of the ceiling. And if not, it's gonna like throw an error instead of like panic. Yeah, we can like simplify the code a bit. Oh no. Okay, so far so good. Now we go back to the transfer. How the transfer gonna work? Like we wanted to transfer from the origin to the specified account destination, and we specify the account ID, which is the destination, and also like the value that we want to transfer. So the value gonna be like the balance type. They're gonna transfer. Very simple, right? So how does it work? Gonna like when you transfer, the total issuance gonna keep the same, but the balances gonna be reduce from the origin and increase for the destinations. Now we go to the balance and we mutate, but here's use key destination, and we want to mutate with the value, transfer from the value, and we can use like tag to tag from, no, not tag, but we also like need to mutate from the origin suicide origin. Oh, sorry, this should be the value. Check soup. So reduce from the origin, increase the balance of the destination. Let's check. So our code compile now, but the problem here is instead of like throwing overflow underflow here, we want to throw an error that like it doesn't have enough balance. So we have to add a new error type. So let's call this error and then enum error. What? And we want to a new error that like not enough balance. Doesn't have enough balance to transfer. Where's the error type? Okay, so the error doesn't need config, but only the T, not enough balance, then balance error. Why is it an error? Oh, okay. Okay, so our code compile. We have a new error called not enough balance and doesn't have enough balance to transfer. And we want to check like if when you check subs, like when you reduce from the sender and the sender doesn't have enough balance. So let's call it sender instead of like origin. And when you transfer from the sender, check subs and If it doesn't have enough value, it's gonna throw error, not enough balance. But there's one thing that there's a case that like when you transfer to the account, it's already hit the limit. So instead of like throwing the overflow for this case, I would rather want it to just saturating and return the remainder back to saturating at the value and return the remainder saturating at the value, return the remainder back to the account or back to the sender. I can say like it doesn't have to return back, but yeah. So the value and return. So we want to get the old balance. The old balance gonna be 0. Gonna be the balance. And the old balance we're gonna reduce, subtract from the new balance. Here we wanted to return try mutate, dispatch error, and we will return the balance as a value of this try mutate method instead of just an empty value here. So let's see. We can also do saturating. Just wonder. Okay. What we're gonna know is old balance and the new balance can never. The old balance and the new balance can never return a panic, even when you do this. So in fact, like you can return B old balance, and we get it as the remainder. And when you got the remainder ready, when you check subs, we want to sub the value from the remainder. But in fact, like you also want to know the actual number of that, like just reduce from the destination that they just add it to the destination instead of just they substitute it from the sender. So you're gonna really saturating subs this value, saturating sub this value from the remainder. So it's gonna return the actual number instead of that one. Yep. increase the balance of the destinations, and reduce, we change the command to decrease the balance of the sender. And with this check subs and saturating it, we're gonna like keep it safe. So we can also like command this, so never this never panic, sorry, this never panic because B is saturated. Yeah, this is the new balance. The remainder. No, not this. Actually, not the remainder, but increase value. Actually, we can also keep it simple that this value just okay. Let's show if it's correct or not. But yeah, I think I hope you get my idea. Now we go back, and what we have now, the transfer. Also, we get the remainder, insufficient balance, non-existent account. Oh, so there's one thing that like in the guide, it's asked us to, so if like there's no balance, we want to throw an error from this account. But I think like it's not necessary because like you already like throw an error that not enough balance here. So I don't think that it's necessary to check that. But we can also like do that if we want. Yeah, but I would rather like put it here. But like the flow of subtree, whenever like there's one piece of code, it's panic, then like everything stops and it doesn't write to the underlying database layer. So it's not a big problem that like if you keep the code in the bottom instead of like on the both. But I think I'm still happy with my code, and yeah, I think it's look the same, so no problem. Check subs, not enough balance. Yep. Okay, so the next thing gonna be, oh, I think like here in the guide, it's also like go to some key component that in the code that I think like I would want to explain it to you guys a bit. So first about the origin and also the account ID. Yeah, you might wonder like where is this account ID, and this account ID is actually coming from this frame system config. So when you go to the frame system config, you can also like find there's a type account ID, and this is where the magic account ID coming from. And what we are configure the palette here is called type coupling palette configurations. So in that case, like if you want to configure the palette, our current palette, you also like need to like the runtime also like need to configure the frame system. So we will want to go to the runtime a bit so that you can understand it in a more detailed ways. And you remember that we already like configure our example with the instant here, right? I think like to simplify the code, we don't want the instant, but keep it just, you know, one single instant of the template, and instant 2. So if you remove this frame system config, everything gonna throw an error, because like actually all the palette here relies on that frame system config. The frame system config, the frame system palette in Substrate is used by most of the palette, like I can say like all the palette, and So and the frame system is gonna like provide some necessary informations to the change, like the block, the versions, the account data, or you can see like also like the account ID. Yeah. Now we already have to address. Now we already have two dispatchable functions. So let's say like what is our next step. Here is also like explained to you about the ensure side, and the ensure side like, is make sure that the origin already decided by the account. No, the transaction submitted is already decided by the origin. And when you want to learn about the origin, there's also a documentation about the origin over here that we can also like quick go to it. So the origin is not an account ID. The frame origin abstractions allow you to convey the meaning far beyond just an account ID being the caller of an intrinsic. Nonetheless, an account ID having size an intrinsic is one of the meaning that an origin can convey. These are commonly used from system in suicide where the return value happens to be an account ID. So simply speaking, origin is different from account ID. Origins has more than that. You can provide more check to the origin. In terms of like consensus mechanisms, the origins case it can also be the validator, the stacker, instead of just the account ID or the user. On the other hand, like the account ID can also like become a whole DAO. So let's say you have some kind of palette, call it palette community, and you want to see like each community, or maybe like palette multi-signature wallet, and then you want to see like each multi-sig is an origin. So the multi-sig can submit transactions, and the transaction submitted by the multi-sig can be acted as the origin and signed by the multi-sig. And how to cite the multi-sig, that you can also like provide the extra side extension to your transaction that is must be signed by multiple key of the multi-sig instead of just one key from the normal user. That's how the origin work for. Dispatch result. Yeah, they also like explain what is the dispatch result, so you can understand it more. The dispatch result just basically a very simple type that wrap like the result in Rust. This result, the result that return an error called dispatch error. The error that we define for our palette, not enough balance, if you remember, that one is also a dispatch error. But a dispatch error is also like can have more than that. So when you want to read about the underlying of the dispatch error, and you can also like find more information about it here. So when you search for dispatch error and you read the documentation of it, the dispatch error can have a few other type, like the tokens, like an error to do with the tokens, or arithmetic, like the one that I just used, arithmetic error, underflow, overflow. That one is also like coming from this dispatch error. Or you can also like have an error with the choice underlying database. The root origin is not low. The bad origin cannot look up the account interchange, or also like consumer remaining. This one usually like used for the balance related to the balance of the account. And yeah, I think like this is very straightforward. So just imagine like dispatch error is at this level, and the one that we use for the palette, the error that we specify in the palette is on top of the dispatch error on another level. This wrap over this dispatch error. Now let's see, like we want to improving the error. How we handle error in the above snippet is fairly rudimentary. So let's see like how can this be improved. Let's see like how what they want us to do. Ensure. Oh, so they want to use the method ensure, but I think like it's not in our case. But basically, you can also like go for revise some kind of this format. Ensure sender more than the balance that is returned. Also better check. Then you can use check subs. Okay, also this is the syntax that I use. Right. Okay, now go back to our palette. What I want is like I want to provide an event aside from the error. So when let's provide two events. This is not in the guide, but I also like want to provide two event called palette event And these two events, the first one called minted, and the second one called transfer. So for the minted palette, for the minted event, sorry, that we want to see like how much is minted, the balance, and who minted it, the minter, and the destination that is minted, also like the account ID. About the transfer, we want to see if the sender, who is the sender, what is the destination, and the value transfer. Maybe we can also do timestamp. Block number 4 timestamp. Here like we get like the block number on the change. As you see like how powerful the palette is, more than the smart contract, that you can get the block number as well. You provide the timestamp. So we also like want to deposit events, and as I remember that we also like need to provide a few other code, but let me take a look. If you want to emit an event, deposit event. Here, generate function. We need a new function to emit an event. This called generate deposit. Below, I'm gonna call this method deposit self deposit event, and this is gonna be transfer. Sender value and timestamp. So our sender gonna be sender destination value and timestamp. We're gonna call the frame system palette, and we get a number from this one. We got a timestamp, which is our current timestamp. And what happening when you run cargo check? Does work, and can we also like deposit a new event for the mint? Minter here. Our code doesn't compile. That's interesting. Config. Oh, because like we doesn't specify the runtime event. So when you look at other palette, so let's say like here, I go back to the asset, and you're gonna see like the runtime event, also like configure for this asset. Just copy it over. You don't have to care about like what is work under the hood, because it's basically just configure some kind of runtime event that you need, and using runtime event, and then like when you go to the runtime, you have to add it to your minimal template. Runtime event. Let's see if it's work now. It's asked for the instant, but in fact like it doesn't need that. But we can also follow. Do we need that? I don't think so. Okay, we're quite close to that. We already specify the event, but there's also a few things that we have to work on. So here's ask for the value, but because we doesn't have the value, I think that we can change the parameter name to value. Okay, it makes more sense to me. Run calculate check again. It say like doesn't have any account ID. So yeah, there's a typo. Not a big deal. Value is borrow. This should be fixed, right? Need to reference. Okay, so our code is compiled successfully.